Operations on radical expressions, part 2. First, let's recall. If the index is a positive even integer, for example 2 or 4 or 6 or 8, and the radical is a negative number, then the radical itself is not a real number. For example, the square root of negative 9 or the fourth root of negative 8 are not real numbers. But if the index is a positive odd integer, for example, like 3, 5, 7, 9, and so on, and the radicand is a negative number, then the radical is a real number. For example, the cubic root of negative 27 and the fifth root of negative 243 equals to negative 3, which is a real number. Now, keeping this in mind, let's recall the product property of the radicals that we discussed in part 1. So what this property said, for example, if we wanted the nth root of a times b, which is a product, we can write this as a product of two radicals. So this is equal to the product of the nth root of a and the nth root of b. So now, keeping this in mind, if we go backwards, so in this way we went in this direction. We wrote a product of a radical into a product of two radicals. Now we can go into the other direction, and we have the product of two radicals written as the radical of a product. Okay, so in other words, the nth root of a times the n root of b is the same as we write a and b under the same radical when the index was the common index. This is important. If we want to multiply two radicals, we can do this only if the indexes are the same. For example, I can multiply the fifth root of 3 with the fifth root of 13. So we can write this as the fifth root of 39. Why? Because the indexes are the same. The radicand, it doesn't matter. So using this property, we go now and do some examples. For example, example 1. I want to multiply these two radicals, and the first thing that I have to check if they have the same index, yes. The index is the same. In this example, the radicand are the same, but it doesn't matter if they are different. What matters? Matters the index. So, based on this property, I can write the common index, okay, which we don't write, and now I will multiply the radicands. Okay, I can write this as 3 squared, or I can write this product as 9, and in both cases, the root is 3. Okay, so why I did this example? Because I want you to recognize. So what I have the square root of 3 times the square root of 3, which is directly 3. Or if you have a radical, the square root of a product, two numbers multiplying, a number multiplying itself, so this is 3. Also, if you have 3 squared, the exponent on the radicand is equal to the index, then you get a 3 outside. And also, if you have the square root of 9, which you are familiar, so this is 3. All these three cases are the same. So again, the square root of 3 times the square root of 3, exactly the same radical multiplying itself, just write the radicand, 3. If you have a product, a number multiplying itself, a couple of the same number, so this is 3. If you have a square and the index is the same with the exponent of the radicand, then the base is outside. For example, let me give you another example here. If I have the index 5 and I have 3 to the 5th, the same index, means you divide and you get the base outside free. Okay, and also for the square roots of perfect square numbers, you are familiar. So keep in mind again, a radical multiplying itself exactly, it is the radicand itself. And also this double product here. Now let's go and do some more examples. Now, may I multiply these radicals? Yes, because the index is the same, they are both square roots. Now, what the property said? The property said that I have to multiply 7 and 14. Okay, now I am not going to multiply because this will give me a large number, but what I notice here, I notice that 14 is 7 times 7 times 2. So I write 7 times 14, I write 7 times 2. You know, this is 7 times 2. Why I'm interested? Because this couple of 7 here is free outside, is the root itself. So this is what? 7 square root of 2. Okay, what I did this. So if you want, you can multiply, which is 49 times 2, separate. And you know that this is 7 times 2. You don't need to do this. As soon as you get a couple of 7, just destroy it and send it outside as a free number, because this is the root. Okay, you don't need to go and to multiply. For this reason, I said before, I emphasized when I work on the first example. So this is 3. Or you can work like this. Don't go and put them inside. Just figure out that 14 is 7 times 2. Separate them. Separate 14 as the square root of 7 and the square root of 2. And now you have this, which is 7. And you have the answer. And I'm going to work like this. Now, example 3. I have to multiply the square root of 5 with an expression. And what do we know here? We know that we have to use the distribution property. But I'm multiplying by the square root of 5. Let me go and distribute. The square root of 5 times the square root of 35 plus, let me write this 2 first, because I cannot multiply 2 with a square number. Okay, this is the square root number. So 2 square root of 5, and now I can write square root of 5. In multiplication, the order doesn't matter. So write this first and then distribute the square root of 5 that is in the front. Now, exactly here, you don't need to go and to multiply to make this 25, okay? Because this is just 5. And now I will write 35. How? As 5 times 7, because I'm interested, okay? And now let me separate. I have the square root of 5. I will separate 35 as square root of 5 times square root of 7. And now I know what is this. Let me continue. This is 2 times 5 is 10. And what I have here, I have 5 square root of 7 plus 10. Done. So here you can multiply, make this 25, but why to spend time and rows when you know exactly now? If you have exactly the same radical multiplying itself, the root is just the radicand, the common radicand. Okay, now let's go to the example 4. The same, I have to distribute Be careful, you cannot multiply a number with a square root, okay? Just let me rewrite. So what I have here, I have the square root of 2 times the square root of 10 minus, let me rewrite the second, 7 square root of 2 times the square root of 2. I'm happy to see this. What is this? I'm going later. So what I know about 10? 10 has a 2 inside, so I write 10 2 times 5. So what I have the square root of 2. I'm separating the square root of 10 as the square root of 2 times the square root of 5. Why? Because I'm interested for a couple, which is number 2. Now I have 7 times 2. And let me go again. So this is 2 square root of 5 minus 14. And I'm done. Again, example 5. I have to distribute. Let me go. The square root of 3 times the square root of 21 plus 8 the square root of 3 times the square root of 3. Happy to see this because this is 3. And now I'm happy to see 21 because 21 is 3 times 7. Let me separate now. 21 as the square root of 3 times the square root of 7. Happy to see this number 3 here. Plus 8 times 3. And I have 3 square root of 7 plus 8 times 3, 24. Done. As you see, the last row I cannot combine because they are not similar terms. So this contains a radical and the other not. Example 6. Again, I have to distribute. What I have here, I have the square root of 7 times the square root of 21 minus, let me write this, 3 square root of 7 times the square root of 7. Happy to see number 7 here. And happy to see inside 21 a 7, 7 times 3. Let me separate now. So what I have, the square root of 7 times the square root of 7 times the square root of 3. So I separated the square root of 21 written as the square root of 7 times square root of 3. Why? Because I'm very happy to see number 7. Minus 3 times 7. Again, what I have 7 square root of 3 minus 21. They are not similar terms. Done. Let me distribute now 6, the square root of 6 into the binomial. So what I have here, I have the square root of 6 times the square root of 42 plus 5 square root of 6 times the square root of 6. Happy to see number 6. Happy to see inside 42 a 6. So write 42 as 6 times 7 and separate. So the square root of 6 times the square root of 6 times the square root of 7. Happy to see number 6. Plus 5 times 6. And what I have, 6 square root of 7 plus 30. Done. Let me go now, distribute this, the square root of 5 times the square root of 55 minus 4 square root of 5 times the square root of 5. Happy to see number 5. And happy to see a 5 inside. Why? Because I'm interested. 5 times 11. So write 55 as 5 times 11. Why? Because now when we separate, we have the same radical. So I'm separating 55 as the square root of 5 times the square root of 11. Happy to see number 5 here. Minus 4 times 5. And what I have, 5, the square root of 11, minus 20, done. Okay, now here, example 9, I have to multiply two radicals. I am happy, yes, I can do it. Why? Because they have the same index. So I'm going to use the property. I am writing a radical with the common index, and now I multiply 7 and 11, and this is 77. I cannot find the cubic root of 77 by hand because this is not a cube number, so done. Now example 10, I want to multiply these two radicals, but I cannot. Why? Because the index is different. So I'm leaving, cannot multiply here. Different index, I cannot multiply. Same index, yes I can. Example 11. So I have to distribute the cubic root of 4 into this binomial. So may I multiply? Yes, I can. Because I see the radicals have exactly the same index, so I can go and multiply. So what I have to multiply? The cubic root of 4 times the cubic root of 5 minus 2, the cubic root of 3 times the cubic root, the cubic root of 2 times the cubic root of 4. Okay, now clearly you see that I can multiply. So write them inside the same radical with a common index. 4 times 5 is 20. Minus 2. Multiply them right under the same radical. 2 times 4, 8. Okay, so I skipped a row here. So really I have to write this. 4 times 5 minus 2. 3, 2 times 4. But I multiply directly, okay? And this is going now here. Let me continue. I cannot find the cubic root of 20 by hand, so I leave exactly as it is. And now I have negative 2 times, I know, the cubic root of 8 is 2, and I continue. The cubic root of 20 minus 4, done. Okay, so keep in mind, if you want to multiply radicals, you can do it only if they have the same indexes. It doesn't matter the radicand, but it matters the index. Now, example 12. I have a square of a binomial, and I know how to square this, okay? So what this means? This means that I have to multiply the square root of 3 plus square root of 5 twice. Okay. Now, I can use a formula here. A plus b squared is equal to a squared plus 2ab plus b squared, okay? But if you don't remember the formula, just remember the job of the index is to multiply the base twice. The base is a binomial, so the binomial will multiply itself. How to multiply? Now we have to distribute. We have to multiply the square root of 3 with the second quantity. And now plus the square root of 5 with the second quantity. Okay? So the first with the second quantity, the second with the second. You know this is distribution property. And now let me go. What I have here? I can multiply here. 3 times 3 is 9. Or I can leave the square root of 3 times square root of 3, and I know this is the number 3. Plus the square root of 3 times square root of 5. I can multiply it. 15. Okay? Now, The square root of 5 times square root of 3, yes, I can multiply the same index. 5 times 3, 15. And now, let me go and multiply. So here I left, just for pleasure, here I like to multiply. 5 times 5, 25. Okay, what I have here? Here I have 3. Here I have 2 square root of 15. 1 here, 1 here. And I have 5. And the last result is 3 plus 5, 8, plus 2 square root of 15. Done. So I could work easily if I remember the formula. So let me repeat with the formula. The square root of 3 plus the square root of 5 squared. I know this is the first squared plus 2 times both, the square root of 3 times square root of 5, plus the last term squared. Okay, so I have the square root of 3 squared. I know this is 3, plus 2. I can multiply them because they have the same index. So write the radical, the square root, 3 plus 5, 15. And the square root of 5 squared is 5. And now 3 plus 5 is 8, plus 2 square root of 15. Done. Now let me use the formula for this. Let me recall, this is the formula a squared, a minus b squared. Okay, so this is a squared minus 2ab plus b squared. Okay, so what I am going to do here, I am squaring the first term minus twice the product of the terms plus the second term squared. And now I have 7. The square root of 7 squared is 7. Minus 2. 7 times 3, 21. Plus 3. The square of the square root of 3 is 3. Combine, 7 plus 3 is 10. Done. And the last example, I have to multiply. And if you see, this is a difference of the square. So let me recall you. This is a plus b times a minus b. And I know that this is a square minus b square, a difference of the squares, okay? So I can use this or I can go and distribute. Let me use this first. So if you recognize that this is the difference of the square, so this is equal to what? The first term squared minus the second term squared. And easily I say this is 3 minus 2, and this is 1. Okay, now if you don't recognize this, let me go as we usually do. So I want to multiply the square root of 3 plus the square root of 2 with square root of 3 minus square root of 2. I know, so the first will go and multiply the second quantity, and the second. Let me go and do this. So I have the square root of 3 times the square root of 3 minus square root of 2, and plus the square root of 2, multiplying the second quantity. Let me distribute now what I have. I have the square root of 3 times square root of 3 minus the square root of 3 times square root of 2. What is this? This is number 3. And what is this? This is the square root of 6 plus the square root of 2 times square root of 3 minus square root of 2 times square root of 2. So this is the square root, this is 2, and this is the square root of 6. Let me go and do this. So this is 3 minus the square root of 6 plus the square root of 6 minus 2. So these are 0, and 3 minus 2 is 1. And this was the lesson for today. Thank you very much. So follow me in the next video when I will talk dividing radicals.